I've posted two of the answers in the final exam from January 2013, mainly because the results on those two questions were less than what I expected. In the first question, number 5, it's a percent composition, where two separate experiments are performed to determine the percent composition of an unknown compound. So the question says, an organic compound contains only carbon, hydrogen, and chlorine. When a 3-gram sample was completely combusted in air, 7.04 grams of carbon dioxide formed. In a separate experiment, the chlorine in the 2-gram sample was converted to 2.54 grams of silver chloride. Determine the empirical formula. So 2 experiments were carried out, one with a 2-gram sample and one with a 3-gram sample. So that prevents us from equating the quantities except if we turn them into percentages. And that's what you had to do to unlock the answer to this question. We're told that in the first experiment, 7.04 grams of carbon dioxide was produced. So we divide by the molar mass of carbon dioxide, which is 44.0098, find out that we have 0.15 moles, or roughly 0.16 moles of carbon dioxide, and also carbon, because for every mole of carbon dioxide, you have a mole of carbon. We then multiply by the molar mass of carbon to determine how many grams of carbon were in that 3-gram sample. So from there, we can now determine the percentage of carbon in the sample. The next experiment allows us to determine the percentage of chlorine in the sample. And once we have the percentage of chlorine and the percentage of carbon, by subtracting from 100, we'll be able to obtain the percentage of hydrogen. That's the trick to solving this problem. So 2.54 grams of silver chloride formed. Here's the molar mass of silver chloride. This is the silver, this is the chlorine. That's 1.7 times 10 to the minus 2 moles of silver chloride, and the same number of moles of chlorine. Because for every mole of silver chloride, you also have a mole of chlorine. We multiply by the molar mass of chlorine to tell us how many grams of chlorine were in the original 2-gram sample. Now that's going to allow us to also establish a percentage. And that's what we do here. 0.62 grams of chlorine divided by the 2-gram sample mass times 100 gives us 31% chlorine. 1.92 grams of carbon divided by 3-gram sample in the first experiment gives us 64% carbon. Now that we have them as percentages, we can equate these two experiments because a percentage takes into account the mass of the sample. So we have 64% carbon, 31% chlorine. The missing percentage has to be hydrogen. So that's why we subtract these two numbers from 100. We get that the sample is 4.54% hydrogen. We then assume a 100-gram sample, which allows us to turn all those percentages into gram quantities. We divide by the molar mass of each substance, and we get this mole fraction, or mole proportion for a 100-gram sample. We divide by the smallest number in the ratio, and the result is roughly 6, 1, and 5. So the empirical formula of our unknown compound is C6H5Cl. The last question in the exam seemed difficult, but again made use of a simple strategy. You had to recognize the fact that the percentage was not 100, which meant there was something that was unaccounted for. And by assuming a 1 mole sample, you would be able to unlock the answer to this question. Perfect timing today. Koalas eat eucalyptus leaves, which contain eucalyptol, composed of 77.87% carbon and 11.76% hydrogen. The mass of the substance is 154 grams per mole. What is its empirical and molecular formula? So, if we assume a 1 mole sample so that the missing mass, notice how the percentages do not add up to 100%, and that should tip you off as to why we have to assume a 1 mole sample. It can be recognized as the multiple, the missing mass can be recognized as the multiple of the mass of some element. That's why if we assume a 1 mole sample of the element, you'll know that we'll get an integer value for the missing amount of element. So we take that 154 gram mass, multiply by the percentage of carbon, we get 120 grams of carbon. Same thing for hydrogen, we get 18 grams of hydrogen. We divide by the molar masses of each respective element, and we get a proportion of 10 and 18 10 to 18 for carbon and hydrogen. Now, if we subtract the mass of carbon and hydrogen from the total 1 mole sample, we'll get that there's 15.995 grams of mass missing. Well, that corresponds very closely to the mass of oxygen. So that points to the formula, the empirical formula of the atom being, of the molecule being C10H18O1. But we're told that the sample, the molar mass of the substance is 154. If you add up the molar masses of all these substances, you get 154.24, which means the molar mass, the empirical formula, has the same formula as the actual formula. So the two are the same. And that solves the problem.